Okay, so the video quality should be better on this one, or the sound quality. So on this one, we're now looking at rational expressions, which means we're going to have variables in the denominators. So right now, when I see my 12 over xy cubed plus 6 over x squared, I can tell these are not like terms because my denominators are not the same. Now with variables and monomials specifically, so all multiplication, we're just looking for our LCD to have the highest power of each variable. So when I look at my x's, that's going to be x squared, and my y's are going to be y cubed. And the idea is if we take those highest powers, we're always going to be able to multiply by an x or an x squared or something like that to create that common denominator. Looking at my first fraction and my goal, which is my LCD, if I just multiply this denominator by x, that's going to create x squared y cubed. And we know we have to do the same thing to the numerator and denominator, so we're multiplying by 1. On the other fraction, I need y cubed. Okay, so we're going to multiply these out now. So looking at our steps, we found the LCD and wrote it on the side. Our goal was to get each rational expression to have the LCD. We multiplied both the numerator and denominator by missing factors, and we don't need to use distributive property on this one. A big point, it's common to cancel. In a second, we'll look at that. So I have 12x, we're doing this one, over x squared y cubed. And then I have 6y cubed over x squared y cubed. Now, because you put in something that could be considered a common factor, you can always cancel at this point. For example, in the second fraction, I have the y cubed. But if I do that, I've pretty much undone what I did so I could add the fractions together. So now we're going to add the numerators together. And basically, the numerators are the number or amount of whatever we have. And we're going to keep that common denominator because that's the type of term. And it gets more abstract with these variables. But basically, I can't actually add those two numerator terms together, so I'm just going to write them in a row. So we have 12x plus 6y cubed over the common denominator, x squared, y cubed. So if we could have combined those two terms together, we would have, but ultimately we're just trying to create that one fraction. So this is my final answer. We do look to see if we can reduce the resulting fraction. Here we have a binomial in the numerator, right? So we can't cross off that y cubed, nothing really factors, so that's our final answer. I suggest you kind of working through these remaining problems. I do actually, hold on, we'll do this one together specifically because something interesting is going to come up on this one. So we look at these two fractions. My LCD, so I have monomials. We're not going to get into anything with binomials until the next video. So for those numbers 5 and 10, my LCD would be 10. And then my highest power of the variables is just x. So my first fraction to get to 10x needs a 2. And my second fraction needs an x. So we're going to multiply this out. Here's that situation where we need the distributive property. So I have 8x minus 2 over 10x. And in my second fraction, I have x squared plus 5x over 10x. Now the piece that's a little tricky about this one is that we're subtracting this whole second fraction. So we're actually subtracting both of those terms in the numerator. So kind of like polynomial long division, it's not polynomial long division. We need to distribute this sign, so we're going to make this addition and change both of those signs to subtraction. So we can bring this together now. I'm going to write my highest powered terms first. So in my numerator, when I put all of this together, I have negative x squared. 8x minus 5x is 3x. And then minus 2, and that's all over the LCD of 10x. So I suggest after this one, pause the video, try these remaining 4. I'm going to do them pretty quickly, but you can come back when you're ready. So letter A already has a common denominator, so I'm just going to combine like terms. So this is 6x minus 3 over 6x. Now this one, we can actually simplify. So here, if I look at my numerator, I have a common factor of 3. In my denominator, I just have that 6x. Now, since the 6x is a monomial, I can actually cancel out and make this a 2x. So now we have, and I know it's getting a little crowded here, 2x minus 1 over 2x. There's that minus 1 there, so I cannot cross out the 2x's. And that's my final answer. So that happens sometimes. We just have to check to see if we can simplify at the end. For letter C, my LCD for the number part is 4. For the variables, the highest power is x squared. My first fraction is missing an x, and my second fraction is missing a 2 to get to that 4x squared. So when we multiply this out, I get 3x over 4x squared plus 2 over 4x squared. So when I combine these two fractions together, add our numerators, and keep our common denominator. Moving down to the last two, letter D. My LCD is A and B, so AB. My first fraction is missing the B in the denominator, and my second fraction is missing the A. So we get B squared over AB minus A squared over AB, which is B squared minus A squared over AB. I could factor the numerator into B plus A, B minus A, but that would not cancel with AB. So I'm just going to leave the problem like this. This is as simplified as it gets. So the last one, my LCD is x squared y. My first fraction is missing the y. My second fraction is missing the x. We do have some distribution here. In my first one, I don't, though, because it's at y times y. So y squared over x squared y minus, here we'll distribute xy minus 2x over x squared y. We should notice here that we have to distribute that negative because there's a binomial in the second numerator. So we're going to make this addition, this subtraction, and that addition. So from here, I have y squared minus xy plus 2x all over x squared y. It looks very tempting to start to cancel some stuff, but I can see there's no factoring I can do in the numerator with that trinomial, so this one is done.